Great. Now that we have executed our first code, let's begin by learning how to speak Node.js. And there's no better place to start than learning about global objects in Node.js. For this lesson, I have already created a folder and named it 02 Speaking Node.js. And in that folder, I have created a JavaScript file named 01 Globals. We will write the code for this lesson in this file. In Node.js, there are several built-in global objects and functions that are available for use in your code. Essentially, these global objects mean that you can access them anywhere in your application without needing to import or require them. These objects are part of the Node.js runtime and are always present in the global scope. However, the emphasis of this module is to give you an overview of the built-in global objects in Node.js and not to cover every single one of them because there are a lot. But as we progress with the course, we will implement them and you would see them in action. We will be looking at 7 common and useful global objects in this lesson. The first global object we will look at is the __ file name. This prints the full path of the current file you are working in. Let's have a look at its value by logging it. So we go by console.log __ file name. And we can see it gives us the full file path of the current file we are working in. Good job. The next we'll look at is the __ dir name. What does this do? This prints the directory that the current file is in. Similarly, let's go ahead and log this value. And we can see the directory name of where we are. The third we will look at is the module object. The module object represents the current module that's being executed. And an important property of the module global object is the module.exports. We will use this function throughout this course to define what we want to export from a module. Next, let us examine the require object. The require object takes a parameter of ID and it is used to import our modules or to import JSON files and local files into your application. Let's test the require object by importing the local module that we create. We set things up by right-clicking on the Speaking Node.js folder and choosing New Directory to create a directory called path. In this path directory, we will keep all our utility files. In the path directory, we create our local module and call it current local module. And in it, we will define a const variable called local module and set its value to current local module. Now we want to have access to this const variable in our global.js file. So we would use the modules.exports to export it. Back in our global objects file, we would define a const variable and set its value. We would require the current local module file we just created. We don't log our value. So this is how we use the require object to import local modules. Next, let's use it to import a JSON file. We would use the require object to import a JSON file. Still in our path directory, let's create a JSON file and name it jsonfile.json. In it, we'll create a simple JSON object. Now let's go back to our global objects file. We would then define a const object named JSON data and set its value. We would require the JSON file we just created and log our value to the console. Good job. Now that you have a clear idea of how to use the require object to import local modules and JSON files, next, let's talk about the process object. The process object provides information about the current running process and allows you to interact with it. The final two objects we will look at are setInterval and setTimeout. SetInterval and setTimeout are global functions that allow you to execute a callback function after a specified time. The setInterval will execute the callback function repeatedly at the specified time, while the setTimeout will only execute it once. Let's console log hello world and use the setInterval and setTimeout. Now we have an overview of some important global objects. Remember, there are so many more of them, and a link will be provided at the end of this section, which you can use to explore them further. So see you in the next lesson. Excellent. Now that we understand the globals in Node, let's talk about modules. As we build our projects and they become more complex in size and functionality, not only will it be very frustrating to write all your code in just one file, but it will be extremely difficult to maintain our code. And that's why we need modules. A module in Node.js is simply functionality that is organized in a simple or multiple JavaScript files and can be reused throughout our applications. In a simple term, a module is encapsulated code. For this lesson, I have created a JavaScript file named 02 modules. We would write the code for this lesson in this file. Node.js has three major types of modules. We have the local modules that we create. We have built-in or core modules that come with the Node.js runtime. And we have third-party modules that we can import by running the npm command. In this lesson, we'll talk about the first two. The first is the local modules. Local modules are modules that we create locally in our Node.js application. We use these to separate the functionality of our application over several separate and manageable files and folders. If we choose, our local modules can be packaged and distributed via the Node Package Manager (npm) to be used by the entire Node.js community, making them third-party modules for other users. Now, let's create a local module in our path directory that performs multiplication on two numbers. We would then require and use this local module. So we'll define it as a const, multiplied values, and it takes two values as a parameter and returns the multiplied value of both of them. Next, don't forget to use the modules.export to export the multiplied values. In our 02 modules.js file, we create a const variable. Now, we set its value by requiring our multiply.js module that we just created, and we pass in two integer variables and log the results. As we can see, we have successfully logged the two values of 5 and 6, and we have a result of 30. Good job. Now let's talk about core or built-in modules in Node.js. Node.js has several inbuilt and extremely useful modules that handle various aspects of our application functionality. These modules are loaded automatically when the Node.js process starts and must be imported to be used in our application. We would examine 4 of these modules. The first is the OS module. The OS module provides utility methods and properties related to the operating system running the Node.js application. What does this mean? Well, let's write some code to access the OS module and execute some of its properties. We first begin by importing the OS module. Now let's get some information about the current user by running the os.userinfo command. When we console log, we can see the result. Next, let's write some code to see the system uptime and console log the results. Finally, let's create an object of OS properties and log the results. This object will contain the OS type, the OS release, the total memory, and the total free memory. Now we can log the results. Great. The next built-in module that we'll look at is the path module. This module provides utility methods for working with the file and directory paths. Let's examine a few of its properties. The first path module property we will examine is the path.sep. This provides platform-specific path segment separators. If you're on a Windows machine and you run this, it will give you a backslash. If you're a Mac or Linux operator, it will give you a /. So let's run this and see. You can see that I have a / because I'm running on a Mac OS computer. If you find yourself on a Windows computer, it will be a backslash. Next, we will look at the path.join method. What the path.join method does is that it takes the segments of a path as parameters, and all given path segments provided to this path method are joined using the platform-specific separator. Let's write some code to show this. As you can see, the parameters we have given in, and now we console log our results. Next, we'll consider the path.basename method. This method returns the last portion of a path. Let's go ahead by supplying as an argument to the path.basename method the file path that we just created. We can see that it prints out the last segment of our file path. The final path method we would explore is the path.resolve. This method takes a series of paths or path segments as parameters and resolves them into an absolute path. Let's go ahead and log our results. Great. The next built-in node model we will consider is the file system module. The FS module enables us to interact directly with the file system from our Node.js application. All file system operations have 2 forms. You have the synchronous or the blocking type and the asynchronous or promise-based type, which we call non-blocking. We would revisit the concept of blocking and non-blocking code in the lesson on event loops. But for now, just know that blocking code is any code or group of code that prevents further execution of code until it finishes its own execution. Conversely, non-blocking code does not prevent the execution of further code. It executes asynchronously. Now let's write some code to read a file synchronously and asynchronously. To read a file synchronously, we use the fs.readFileSync method. Let's create a dummy text file for our purposes. The fs.readFileSync method takes two parameters. The first parameter is the file path, and the second parameter is an encoding option. We would use UTF-8. Now let's log our results. Good job. Now let's read the same file asynchronously. fs.readFile is the asynchronous version and it takes three parameters: the file path, encoding option, and a callback function to handle either an error or the result of our operation. We finally log out our results. Outstanding. Now let's try to write files both synchronously and asynchronously. As with read file, we write files synchronously using fs.writeFileSync. Let's again create a file and name it new file text for our purposes. The fs.writeFileSync also takes two parameters as arguments. The first is the path to the file to be written into, and the second is the value to be written to the file. Let's now view our results, and we can see that the value hello world has been written to our file. The fs.write file is the asynchronous version and it takes three parameters: the file path, text to be written, and a callback function to handle either an error or the result of our operation. We finally view our results. The final module we will consider in this lesson is the HTTP module. We would primarily use the HTTP module to create web servers and set up APIs in this course. This section will briefly introduce how to create a web server with our HTTP module. To create a server, we utilize the http.createServer method. This method accepts a callback function as parameter And this callback function then accepts two object parameters which are called rec and res by convention. We will specify what port our server is listening on. In our case, we'll use port 3000. The rec object represents the incoming request. Consider a client making a request for a web page from her browser. Information about the request method, whether the request method is a get, post, patch, put, or delete, and other useful information are stored in the rec object. The res object contains everything that we'll be sending back. As a side note, if none of this makes sense, don't worry. We are going to dive deep into the rec and res objects and creating servers in this course, and all will be made clear. So to keep things simple at this stage, we will use the res object to send back a string as a response, and then we would end the response. Run the project to start the server, then go to your browser and enter localhost/3000. Localhost in this case refers to your computer, which is acting as a local server. Great, now we can see our response in the browser. Let's consider the rec object. The first property we would look at is the property to get the URL entered by the client. When getting the rec URL, the / is commonly used to signify the home page. We would also like to have different responses based on different URLs. So using the if-else statement would work well. We would also like to have different responses based on different URLs. So using an if-else statement would work well. We check for the request URL property, then respond with different messages depending on its part. If the URL contains /about us, we serve the about page. If it contains /contact us, we serve the contact page. And if it's just a /, we serve the home page. Finally, if the path does not exist in the if-else statement, we respond with page not found and also right head of 404. So see you in the next lesson. Excellent work. As we build our Node.js applications, it's important to note that whatever challenge we encounter while building our app has most likely been encountered by someone else somewhere, and that person has successfully solved the challenge and shared the code with the entire world. Our job is now to add this solution to our project with one command, and that's npm. npm stands for Node Package Manager, and it enables us to do three things. Number one, reuse our own code in other projects, reuse third-party codes in our projects, and share our solutions with other developers. The npm project with all its packages is hosted in npmjs.com. Here we can find everything from simple utility functions to full frameworks and libraries. A typical Node project would have several npm packages installed as dependencies. npm is installed by default when we install Node.js. This gives us access to the npm global command. We can confirm the npm version by typing npm-version or npm-v in our terminal or command line. There are two ways to include npm packages in our project. We can create a local dependency, or a global dependency. Installing a npm package as a local dependency means that the package will only be used in the project being developed. The command npm I package name is used to create local dependencies. Installing an npm package as a global dependency means that we'll use the package in any project. The command npm I-g package name is used to create global dependencies. For Mac computers, we add the sudo command. We would use local dependencies more often in our projects. Brilliant. Before we learn about packages, let's first confirm our npm installation and version. We can see that npm is properly installed in our machine. With that out of the way, let's talk about packages. A package in Node.js is simply a folder that contains all the JavaScript files needed for a module. It's what we download using npm when we want to install third-party code in our projects. A crucial file worth mentioning that we need to include in all our Node applications is the package.json file. You can think of this file as a manifest that stores important information about our project and all its dependencies. There are two ways to create the package.json file. We can manually create the package.json file in the root of our project and add all dependencies, properties, and everything that is needed. To do this, we right-click on our project and choose New, Package.json file. This file is created for us. We can edit it as needed. Now let's delete it and try another approach. The second and more common approach is to create the package.json file automatically by running npm init in the terminal. We then click enter to accept all the values. There's a slight flavor to running the npm init. If we want to automatically accept all the default values, we run npm init-y. So why do we need the package.json file? We need this file because as we install packages with npm, these packages are stored as dependencies in the package.json file. Finally, let's talk about the node_modules folder. All our dependencies are stored in this folder called node_modules. This folder is in the root of our application and is automatically created by npm when we install packages. To see this in action, let's install a package named package by running npm I package. This package adds no particular benefits to our project and is just for testing purposes. Now, if we take a look at our package.json file, we see that it is added as a dependency and a new folder called node_modules has been automatically added to our project. Inside it, we can see our package. The final thing we will look at in this lesson is how to uninstall a package. To uninstall a package, we run the command npm uninstall and the package name. Let's uninstall the package we just installed. Now that it is uninstalled, if we view our package.json file, we see that it is no longer there. And also in our node_modules folder, it has been deleted. Okay, so that's all for this lesson. Once you're ready, head over to the next lesson where we'll learn about the core concepts of event loops. See you then. Event loops are a fundamental concept in Node.js. They are what makes Node.js Node.js. But to understand how the event loops operate, we must first understand synchronous programming and how JavaScript processes code. Imagine, if you will, a restaurant that has only one chef and one waiter. The way this restaurant operates is that the waiter takes the order of one table to the chef and does not attend to the next table until the chef has completed the meal of the current table. This is how synchronous programming operates. JavaScript is a single-threaded and synchronous operator, which means that it reads code line by line and does not go to the next line until the current line is complete. If the current line of code is a long-running process that takes time, the subsequent code just has to wait until the current task is complete. Node.js solves this JavaScript drawback by using the event loop to make its operations asynchronous. In a synchronous operation, Node.js doesn't have to wait for a task to complete before going to the next. It proceeds to the next task and comes back when the result of the previous task is ready. An event loop is a continuous loop that listens for events and executes callback functions when an event occurs. It continuously checks for new events or tasks and executes them as they become available. As a result, Node.js is able to handle a high volume of requests without blocking the main thread of execution. Let's code an example to see the event loop in action. In our code, we write several lines of code to represent tasks to be executed. The first task is an action to log a simple string. Then we create a function to read some text asynchronously. Our second task is also to log some string to the console. We then use a setTimeout callback function to signal the completion of the second task after 0 seconds. And we run our read file method. Finally, we signify that all tasks are complete. In a synchronous programming scenario, we would expect that each of these would run one after the other. But watch what happens when we run our program. Both methods that have callback functions are only called when their data are available and are not called sequentially. If we change the time in our setTimeout method, we can see that it is even called later, but never sequentially. This is the power of the event loop, even if on a small scale. An understanding of this is extremely crucial, and links to valuable resources will be provided at the end of this section. Once you're ready, head over to the next lesson where we'll learn about async patterns in Node.js. See you then. Excellent. Async patterns in Node.js allow you to perform tasks asynchronously, which can improve the performance of your application by allowing it to do other things while it waits for a long-running task to complete. Some common async patterns we have in Node.js include callbacks, promises, and async await, which will be used majorly in this project. First of all, let's talk about callbacks. These are the first async patterns we will consider. Callbacks are a simple way to perform async tasks in Node.js. They are functions that are passed as arguments to other functions and are called when the async task is complete. In our code, the read callback file functions reads a file asynchronously and calls the callback function with the contents of the file, or an error if there was an issue within the file. Next, let's talk about promises. The next async pattern we would consider are promises. Promises are another way to perform async tasks in Node.js. They represent the result of an async operation and can be either resolved, which means that they were successful, or rejected, which means that they failed. Here's the same example as when we were doing a callback, but this time we are using a promise instead of a callback. To create a promise, we use the new promise class constructor to create a read file promise function and pass in a callback that takes two parameters, resolve and reject. We then asynchronously read our file and output the result of our operation. With this setup, we can then call the read file promise and chain a then method to output our results, and also chain a catch method to output if an error occurred. The final pattern we will consider is the async await pattern. This is the pattern that we would use throughout the course. The async await is a syntax for working with promises that makes it easier to write async code that looks and behaves like sync code. Here's the same example, but this time we're using async and await. In this example, the read async await file function is marked as async, which allows us to use the await keyword inside the function. The await keyword is used to wait for the result of the fs.promises.read file function, which returns a promise. If the promise is resolved, the value is assigned to the data variable and logged to the console. If the promise is rejected, the catch block is executed and the error is logged to the console. Great job so far. Now that we have learned about async patterns, let's learn about events and event emitters in the next lesson. One of the key features of Node.js is the support for events and event emitters. An event in Node.js is an action or occurrence that happens in the application, such as a user clicking a button or a server receiving a request. An event emitter is an object that can emit or trigger events and execute event listeners or callback functions in response to those events. In our code, let's create a new class and call it myEmitter that extends the built-in event emitter class. We then create a new instance of myEmitter and call it myEmitter. Next, we use the on method of myEmitter to register an event listener for the event. This event listener is a callback function that logs a message to the console when the event is emitted. Finally, we use the event method of myEmitter to trigger the event. This causes the event listener to be executed and the message to be logged to the console. Event emitters are useful for managing the flow of data in Node.js. They allow you to easily trigger events and execute code in response to those events. Now that we have an understanding of events, let's examine the role of streams in Node.js. Once you're ready, head over to the next lesson. See you then. So what is a stream? A stream is an abstract interface for working with streaming data in Node.js. It can be thought of as a pipe that connects a source of data to a destination. Streams extend the event emitter class, making it possible to use events on our streams. When we use the asynchronous approach in Node.js, we read the whole file at once. However, in stream, we read the file in batches. There are 4 types of streams in Node.js. You have your readable streams. These streams allow you to read data from a source. An example of a readable stream is the fs.createReadStream, which allows you to read the data from a file. We also have writable streams. These streams allow you to write data to a destination. An example of a writable stream is fs.createWriteStream, which allows you to write data to a file. We also have duplex streams. These streams are both readable and writable. An example of a duplex stream is a socket connection, which allows you to both read and write data. And finally, we have transform streams. These streams are a type of duplex stream that can modify or transform the data as it is being written or read. Now let's write some code to show how you can use readable streams to read data from a file and a writable stream to write the data to a new file. We first begin by requiring our fs module, and now we create a readable stream from a file. We'll also create this file and call it input.txt. Next, we would read the stream. Next, let's log our results. Okay, going forward, let's now create a writable stream. And we are creating a writable stream to our output.txt file. Finally, let's pipe the data from the readable stream to the writable stream using the pipe method. So in a nutshell, this code reads data from the input.txt file using a readable stream and writes the data to the output.txt file using the writable stream. The pipe method connects the two streams and transfers data from the readable stream to the writable stream. Amazing job! You have come to the end of this section of learning how to speak Node.js. There are some practice activities to help cement and reinforce what you have learned so far. Please don't skip them. Give them your best attempt. And once you're done, let's see in the next section where we'll dive deeper into creating and managing Node.js servers. See you then.